So what I like to do is when I'm keeping track of my resistors, I like to go like this. Okay, 1 over R equivalent for, and I have A, B, and C. I like to go like this and say, okay, 1 over R equivalent for A, B. That helps me keep track of which ones I'm playing with, because half the battle of this is you get really confused as to what you're actually solving. So 1 over our A was 12 plus 1 over 4, and math.
So just 3.
Okay, so R AB is equal to 3 ohms, and that's the R equivalent for AB. So then I go R ABC equivalent. I like to do that. So this guy here combined to become 3, so you can almost think of him at what? You can almost... Alright, so this guy is basically now acting like a 3 ohm resistor in here. So then adding these two together, we get 12 ohms, and that's the answer for A. Okay, then B. Okay, B reads, determine the EMF voltage of the battery. So now we gotta find the battery. If you look at this, they told us that the current going through this 9 ohm resistor was 0.4. So if you kind of look at it in the simplified way, 9 and 3, they both have this 0.4 going through them. Okay, so we can use V equals IR.
And then you can use the 0.4.
So you can use, we're looking for V, which is basically our EMF here. Our current is 0.4, and our total resistance was, again, 12, which we got from here. So, math. So 4.8 volts. Okay.
Oh, wait, I get this.
Part C is where it gets a little bit more interesting. So here's where it gets more interesting. There's actually tons of ways to solve circuit problems. I think the easiest way to do that is this. If we treat this, the combined circuit, as one big 3 ohm resistor between this point, okay? We could say the voltage drop between this point and this point would be helpful to know. The current going through that whole thing would be 0.4, and the total resistance in that area is 3. So our voltage drop is 1.2 volts. Okay, now we can take a step back and we can reinsert those two parallel ones. So we can take this guy back. We can take this guy out, and we can put back in our 4 ohm and our 12 ohm. Okay. Now, they both will not have the currents of 0.4 going through anymore. Okay, it's going to be split up, and it's not going to be split up perfectly half and half. So, but we do know that going from this point and this point, we've got to have a voltage drop of 1.2. So that has to be the same through both. Okay, so there's 1.2 volt drop here, and there's a 1.2 volt drop here. So we can take this, where they want to know the current. The voltage drop through here would be, so V is equal to IR. And again, that labeling really helps. So that, I think that guy was A. So 1.2 is equal to the current. We don't know it, but the resistance is 4, and you can divide and get your answer.
The current.
Okay, hold on. Whoever's listening to this, I went further than I needed to.
Yeah, because it ends up being like, they do it like this, the 4.8 minus the 3.6.
Yeah, you could do it that way. Sorry, I went and got the current. I read it and you needed the current. Here is what they did in the solutions. Okay, I went and found the current, which I didn't even have to do. Sorry, my bad. So the way they did it in the solutions was this. They knew the voltage drop across the battery, which is 4.8 volts. That's how much you're going to have to drop going all the way around, right? So if you knew the voltage drop here to the 9 volts, then all that would be left is what's over going through the parallel part.
Oh, so you just multiply.
Yeah, so they did like basically 4.8 volts, which was the total coming out of the battery, and then they found the voltage drop through C, which was the current was 0.4. The resistor is 9. I don't know what the math is. What is that?
So just 3.6.
3.6?
Yeah. So
3.6?
So again, 1.2.
Yeah. So if you have to go all the way around, get you 4.8. 4.8 minus 3.6 volts would tell you how much you get going between here and here. How much is left?
Okay.